So again, just for the sake of recording, for those who might listen to it later, we're talking about two theorems in this section, and they're both very important. You need to know the names of them, and you need to know what's contained in them. So the first one is Rolle's theorem. Functions continuous and differentiable, continuous on the closed interval, differentiable on the open. F of A, F of B represent the output value. So we have two output values of the function equivalent. Now, these are output values. Are they significant output values? Is there anything special about these output values? They're equal. What else? What's A and B? Yeah, the endpoints of the interval. So the fact that we have a closed interval, and then we're saying that the outputs on the endpoints of that closed interval are equal. Okay, well, let's just write now on your paper, just sketch, put an A, put a B, put a point, my interval's from A to B. If this is F of A, mark down in your papers, where's F of B? Up here? Down here? Here? Where's F of B? According to the theorem, Nash, where's F of B?
Where F of A.
Absolutely, the very same thing. Okay, so on your papers, put F of B there. Okay. Now, we're going to have a closed interval here. We're going to have a continuous function. So I can have a continuous function in many ways. Connect those two dots in any way you want. Any way you want. Use a straight line. Use an arc, a parabola, any way you want. Anyone have something down? Okay. Do we have a continuous function on a closed interval? Yes. Is it differentiable on that open interval? Could you draw a tangent at every point and have a derivative, have a slope of that? Yes. Okay. Are the outputs at the endpoints the same? Yes. If all of that is true, okay, then it says there is at least one number C within A and B. Place C someplace on that graph. C represents what, an input or an output? At least one number C in the interval AB. So C is an input. Where'd you put C? Somewhere between A and B? Okay, well, I'm going to walk around and make sure I see this. Okay, I'm going to put my C right there. Such that there is a C somewhere in that interval such that what happens? What's the conclusion to this? Casey, read it to us. What does that mean to us? Yes. The slope of the derivative is horizontal? I don't think so. I don't know what the slope of the horizontal. Okay, so you're saying the slope of the tangent, okay, of the tangent line, which happens to be horizontal. Good. Okay, now I see where you're coming from. Is equal to 0, which means that we have a horizontal tangent line. There is at least one. What does at least tell us? Could be more than one. We're guaranteed of at least one. Okay? On mine, I have how many? 2 of them. Samip, on yours, how many do you have? Okay? So, here we go. Samip, are you left-handed or right-handed? Okay. Pass that down. Draw what you had on your table. You got to turn it so that the red is in your right hand. Turn it so that the red is in your right hand. No, turn it again. One more rotation. There you go. Okay, so draw us what you have on your paper there. Did you have something on your paper? Okay. Tell us where A is. You gotta show us A. Whoops. Gotta show us A. Okay. Show us B. And where is C? Okay. Now, the criteria is that f of A has to equal f of B. Is that true on yours? Where's f of A? Well, good. Wait a minute, that's not where A is. Where's A on your graph? Yeah, right there. Okay, so f of A is where? Okay? It's a little different when you got in your hands yourself, I know. So, and it's back to me. Thank you. What I see, Samik, on yours is, I see f of A down here, and I see f of B up here. Does that hold by the theorem? No. Okay. So, he was the first person to have to do this. There we go. Someone else. Someone else. Now you're all going to be left-handed, aren't you? Okay. Kim, how about you? Okay, Kim, draw us what you have in your paper. Yeah, you can't look there. You have to look up the board. Okay, so just look at the board. There you go. First place A and B. Okay, and then draw a curve so that it fulfills Rolle's theorem, so it's continuous. Okay. Okay. Actually, f of B would be on that axis also. Okay, so now draw us what you had in your graph. Yeah, I think your hand's on it. Yeah, see, place that up there. Okay. Okay, so where would C be? Okay, good. Are you getting Rolle's theorem? If I ask you on a test, using Rolle's theorem, show that whatever is true, you're going to have to, first of all, show that the endpoints, you have the same outputs at the endpoints. You've got to show that it's continuous. What if the function is not continuous? Would you know that, or would you assume it to be continuous? So if it's not obvious, if it's polynomial, it would be obvious that it's continuous. But if it's not something like a polynomial, you have to go back and make sure that it is continuous. And then if you have to know what the outputs are. If it's continuous, is it differentiable? Can it be continuous but not differentiable? Yeah, we could have something like that. It's continuous but not differentiable. Okay, so we have to make sure that it's continuous and differentiable. And then if all of that is true, we are guaranteed what? What does this guarantee us? Molly, say it for us.
There was at least one.
Okay. At least one. Not exactly one, but at least one. Okay, so that's Rolle's theorem. Now, Determine whether Rolle's theorem can be applied to this function. Once again, is it continuous? So the first thing we have to consider is it continuous? Does it have to be continuous everywhere? Or where? What are you saying? Just on the interval. So what do you think? Is it continuous on the interval? I'm getting a couple of no's out of this. Kevin, what are you saying? Is it continuous on the interval? Why? Where? How? When? So you're saying that at x equaling 1, f of 1 is 0? So what's wrong with the number 0 as an output value? I like 0. It means I have no debt. Is that an adequate representation of why it's not 0 or why it's not continuous? Casey has a comment.
Yeah, it's not continuous because it's undefined when the input is 0.
Why?
Because in a fraction where the denominator is 0, it's undefined.
So if I'm looking at this rational function and I realize that my denominator makes the function undefined and the value that makes the denominator 0 is within the closed interval, okay? Oops, let's do it this way. And -1 is less than 0, less than 1. Therefore, what's my conclusion? Okay, so therefore, we'll put that down Emma first. Therefore, f of x is not continuous. Is not continuous in the interval from -1 to 1, and therefore, what's my conclusion? Rolle's theorem cannot be applied. Which means what? If Rolle's theorem cannot be applied, it means we cannot guarantee what? Guarantee what? Okay. How about just saying cannot guarantee that there is at least one extrema? That works too. Okay, or either way you said it too. Okay, either way. Either way. Okay. Yeah, not only do you need to know Rolle's theorem, but you need to know when and how it can be applied. Now, one thing we haven't done is to say, like, so what? Who cares about Rolle's theorem? What we can say is that given a situation where we want to know, is there a place where our profit is reaching a maximum? That might be nice to know, right? If you're in business, is there a point at which we have a maximum profit? If you have from 2005 through 2008,